Hi everybody, and welcome back. Okay, so I have one more really cool example. This is a more realistic example. I say somewhat realistic example here. And it's kind of trying to tell you, well, okay, if you want to be 99.5% certain that your balloon can get off the ground, how big does it have to be? However, I'm not going to do this one with you. I'm going to be mean. Now, I've given you a whole lot of information here. There's a couple of equations. If you plug these all in right and use your norm.inverse function, you should be able to do it. Remember, you're not going to try to solve this on your own. You're going to use GoalSeek to help you. And as another note, your lift has to be slightly more than 0 to get off the ground. And so you would want to aim for 0 here. That's just the number you should put in. So try that on your own. If you're struggling, we'll do it together in a problem session. Okay? Okay, with that, we're going to go to the last thing we're going to talk about in our Excel Everest knockoff. It's factor of safety. Now, no one ever says make 99.9% certain that this will not fail. They only say make 99.99% certain. No, what they do is that over time we've developed factors of safety that say if you want to build a safe bridge, you have to make sure that the load it is built for is twice what you're expecting to see. Or the load it's built for is 3 times what you're expecting to see. So what you might have is a factor of safety of 2, and you expect to see 1,000 pounds. Maybe your beam is supposed to hold 1,000 pounds. Well, you would instead build a beam that can hold 2,000 pounds. Now, what does that do? Exactly. What does that even mean? Well, let's look at it and see what they're actually doing here. Okay, so here's the certainty I want to have. Here's the average load it's going to hold. And once again, we're going to use the square root of the load to determine the standard deviation. And so from this, we're going to get a factor of safety. Whatever our required beam strength is, over this is our factor of safety. Okay, so equals norm dot inverse, and then I just choose the certainty that's to the left. Okay, I choose my average, which is right here, right there. Okay. I'm still in, it's giving me a time today, 404. Okay, it's selected the wrong one. There we go. Comma, choose this, and I'm going to be very careful. I'm going to make sure I use an absolute reference right there. And then comma, I'm going to take the standard deviation of this. Oh, I moved to the wrong spot. There we go. I'm going to take the standard deviation of it right here. So we're going to take square root of this number right here. Once again, making sure that's an absolute reference so I can drag it down. Okay, so if I only want to be 5% certain that it will be able to hold 1,000 pounds, I can build a beam that's going to be only be able to hold 948 pounds. That's terrible. Don't do that. If you have somebody who's telling you to build a beam that's going to fail, probably won't work for that person. What's our factor of safety? It's a very simple one. It's simply equal to this, whatever you're building it for, divided by this, what it actually is going to be feeling. Once again, just to make sure I don't mess anything up, I need to make sure that this one right here is an absolute reference. Okay, so 0.95. That's not a good factor of safety at all. And now I'm going to drag these down. Without formatting, because I don't like that. Okay. So what you can see is that in this case, a factor of safety of 1.2 is extremely certain it's not going to fail. But you're usually going to see factors of safety of 2, possibly even 3 sometimes. Not all the time, but 2 is not uncommon. Now, why 2? Why 1.6? Why such a huge number? The reason for that is the difference between a dynamic versus a static load. Okay, like for example, let's say you have a 2-year-old. Okay, just a 2-year-old. You could probably lift them into the air fairly easily. You lift them up, okay, got them, you put them back down, easy. Now let's say that somebody else is holding that 2-year-old. They put them just above your hands, so you're not holding their weight, and then they drop them into your hands. Now they don't really drop because your hands are right there to catch them instantly, but you're gonna be like, oh, because it's a dynamic load. It will take you a second to slow them down. And actually the force that you're having to exert, very briefly, is much, much higher than it takes to hold that 2-year-old or to lift them into the air. So that's what's important here. You have to plan for somebody's punching something instead of just pressing on something. You have to plan for somebody to drop a box onto your beam rather than it being set perfectly on top of that beam slowly. Okay? That dynamic load is what's important here. So you want to always over-strengthen things. The second thing is that over time things get weaker. Everything gets weaker. Everything begins to break down with time. And so because of that, you need to plan for that. You need to plan to make sure that even as your wood gets weaker with time, or as more and more cracks get in that metal, or more punches and dents and whatever get into that vehicle, that it will still run safely. So that is why you have to have a factor of safety that's much higher than you expect, because you're planning for the future, not just for today. Now, I hope this helped you. I hope you found this interesting. It's some really good stuff, especially goal seek. Please look at that again. And this is the end of our Excel time together. So hopefully this was fun. Please give me lots of feedback so I can improve it for the future. I'll see all of you next time. Goodbye.